Hello everyone, my name is Ben, and in this video we're going to be taking a look at our newest engine, Noeput, and talking a bit about its functionality, what we hope to achieve with it, and more specifically taking a look at its chamber, which is this component right here. In the next video we will also be taking a deeper look at its injector, which is this component right here. So I've pulled up a cross-section of our engine, and here we can see the inside of the chamber. So to give a quick overview on how an engine like this works, there's an injector which is located about here, and this injects high pressure gaseous propellants into the chamber here where they combine and react, and during this reaction they will expand and heat up, and then these gases are forced down this throat here where they speed up to about the speed of sound, and then from that point they begin to expand again where they continue to accelerate to multiple times the speed of sound. Okay, so obviously the gas inside the chamber is going to be very hot, and the temperature of the gas is significantly higher than the melting point of the metals used in this engine, which in this case is 304 stainless steel. And so to prevent the engine from just immediately melting, we have to actively cool the engine, which we do through two main methods. So the first one is what's called regenerative cooling, which works by running water through these cooling channels located around the engine, and that water just takes off some of the heat that is being put into the engine. And then we actually have two-pass cooling, which means that we have one set of channels that runs the entire length of the engine, then the water goes back up into the second set of channels, which actually stops right here just before the throat. And at this point, all of this water has actually been heated up so much that it's turned into steam, and then we actually dump it out right before the throat, and this is what is known as film cooling. So essentially, this hot steam and this vapor creates a boundary layer between the hot combustion gases and the chamber walls, which is especially critical here since the throat is actually the hottest part of the entire chamber at this point. The final thing that we're going to talk about in this video is the manufacturing process of this engine. As you may have noticed, some of the geometry on this engine looks a little bit untraditional. And the reason for that is that rather than using a traditional manufacturing process, such as machining, we are actually using a process known as SLM printing. This stands for selective laser melting. The way this works is that there is a bed of powder, and then a laser will selectively heat up and melt portions of this powder to create a solid part. Similarly to many other 3D printing processes, SLM printing is what is known as additive manufacturing, which means that it creates the part in layers which build upon previous layers. Due to this, we cannot have overhang in the part that goes beyond about 50 degrees. So for this reason, we are actually going to be printing the chamber upside down, and we have put a lot of consideration and attention into designing each aspect of this chamber to ensure that it is both functional but also something that we can make. Okay, that's it for the chamber. In the next video, we will be discussing the injector.